Hi students, welcome to Icon India EduTech. This is Shekhar Somnath. I am your physics educator. Today we are going to discuss one very important topic in physics. It's a very common, it's a very much practical example of planar motion, that is two-dimensional motion. It's one important component of kinematics. Dear students, today we are going to discuss about projectile motion. Projectile motion, as I told you, is a very nice example, very common, very frequent example of planar motion. We have seen several such kinds of incidents, several such events in our practical life. Students, you go on playground, you play football, you kick football, and you throw very nice shots. If football is kicked and is provided a particular velocity obliquely at some angle from horizontal, it describes a curved path. That is called projectile motion. That is projectile motion of football. However, projectile motion is a very general case. In fact, missiles, intercontinental ballistic missiles, which move up to very large heights relatively, which go up to very large distances as compared to even radius of Earth, those are also considered to be examples of projectile motion. But right here we are talking about this particular you can say event, this particular example from higher secondary point of view, and here our discussion is limited in a particular way, limited in certain regards. We shall consider those projectile motions in which heights involved are very small as compared to radius of Earth. Heights involved are 10 meter, 50 meter, 100 meter, and we shall imagine that projectile or the particle which is moving in curved path above surface of Earth, that is known as projectile. So right here we are considering that projectile is moving in a region of uniform gravity, uniform gravitational field. Here there are certain points, certain a pre-decided lesson plan is in front of you. Whatever I was advocating you, whatever I was telling you, the same thing, the same points are summarized right here. When a particle is thrown obliquely from a point on ground, then it describes a curved path. That curved path later on you will come to know is basically a parabolic curve. When a particle is thrown obliquely from a point on ground, then it describes a curved parabolic trajectory, which is called projectile motion. The particle itself is called projectile. The particle itself is called projectile. In such cases, the height attained by particle is small as compared to Earth's radius. The height attained by particle is small as compared to Earth's radius, and air resistance is neglected. We don't consider any frictional force, any viscous drag because of atmosphere, though it is present. But here at present we shall neglect it, and we shall consider that particle is moving above surface of Earth in a curvilinear path without any air drag. So we shall neglect air resistance, and acceleration, which is because of weight acting upon the particle, acceleration which is due to gravity, that will be considered to be uniform. Reason the heights involved in such cases are very small as compared to radius of Earth. Particle is close to surface of Earth, the heights involved are small as compared to radius of Earth. So acceleration due to gravity g is considered to be uniform. A diagram also has been exhibited right here. This is horizontal surface, this is vertical, horizontal. A particle is thrown from this particular point. The point from where particle is thrown, that is known as point of projection. Particle is provided initial speed u, particle has been thrown with initial speed u, particle has been imparted initial speed u, and particle describes this curved trajectory. P is the particle I have exhibited, I have shown that At a general moment, particle exists, particle is located right here. Initial velocity, this u is actually magnitude of velocity, initial is speed imparted to particle, and direction of initial velocity that has been shown by this arrow that makes an angle theta with horizontal. This theta is known as angle of projection. So here a case of projectile is shown. U is initial speed imparted to particle and theta is equal to angle of projection. So now students, we have this another consecutive, successive, another following slide. It's also concerned to same projectile motion topic. It's ongoing now. There are certain terms or parameters. There are certain terms or parameters associated to projectile motion, to a case of projectile motion. Those very common, those famous terms are mentioned right here, such as R, here R. R is known as horizontal range of projectile. It is basically horizontal displacement covered by projectile. You know, when particle is thrown obliquely in air, then you are providing a horizontal velocity to projectile and simultaneously you are providing a vertical component of velocity to projectile. The projectile, the particle starts horizontal motion as well as vertical motion at the same time. Both the motions are taking place. Particle along vertical moves up, goes to a highest point and then starts returning back. Simultaneously, as long as it is above surface of earth, it is also moving along horizontal, and the combined appearance is projectile, is this parabolic curved path described by particle. So, in this case of projectile, these very common terms associated to projectile motion also are exhibited. First of all, you understand what are those common terms. Those terms are R, T and H. There could be, we can talk about, we can discuss about many points, but these three are very famous concerned terms from projectile motion. R is horizontal range. It's a horizontal displacement described by projectile. Capital T is known as time of flight. It is time duration, it is time interval for which particle remains in air above surface of earth. It is time interval of motion. And capital H is maximum vertical height reached during motion. Capital H, it is maximum vertical height reached during motion. I have exhibited these terms in this diagram also, in this case, in this graphical case of projectile also. A particle is describing this curved track. Particle at a certain moment is right here. Particle started from point O and it lands back on ground right here. Here time was 0. 0 time is initial time. When we started observing motion of a particle, when we start our observation, that is t equal to 0, that is initial time. So particle started at t equal to 0 from point O, describes this curved track and again reaches ground at this particular point. Now time interval elapsed is capital T. Along horizontal axis, along horizontal line, along horizontal ground, you see this separation from O to this particular point where particle falls back, where particle reaches back, where particle lands back to ground, that is known as R. This is horizontal range. During this projectile motion, particle has been at different heights at different moments. At certain moment it was at this particular height, then it was at this particular height. Right now this is the height of particle from this ground datum, from this ground reference level. So during motion, particle has been at different height from ground surface, but at a particular moment the height of particle from ground was maximum, that is this H, maximum vertical height reached during projectile. In this diagram it has been tried to develop a basic understanding regarding R, H and T. So we have enough introduction regarding what is a projectile motion. We understood what is projectile motion, or at least what we have to learn right here. What are our limitations? What are the approximations? What we are neglecting? We understood certain basic terms regarding a projectile motion concerned to case of projectile motion. Now we are gradually coming upon a quantitative treatment concerned to case of projectile motion. So here in the slide we are going to start the same process. Now the question is how to deal with a case of planar motion. You know, projectile motion is example of planar motion, is very nice, frequently observed example of planar motion. As I told you that if you provide a velocity to particle at some angle from horizontal or at some angle from vertical, that can be resolved into two components, and right here we can imagine that particle has been given a velocity along horizontal as well as along vertical. So planar motion is combination of, usually what is our approach to deal with a planar motion, how we analyze planar motion. Before planar motion we have learnt in efficient manner what is straight line motion, what is one direction case. The best possible way, the easiest way to analyze planar motion is that we split it into two straight line motion going on simultaneously at the same time. So that will be our strategy, that will be our approach to analyze this particular case also, to analyze projectile motion also. Planar motion is combination of two straight line motions, one along x-axis and another along y-axis. Selection of x and y-axis also is important, and the solution, the analysis of a particular case depends a lot upon how we select x and y-axis, and usually we go for the easiest possible choice. So right here horizontal is being taken as x-axis, and it's very obvious it will be, though there is not a hard and fast rule that you select horizontal only as x-axis, vertical only as y-axis, but right here it is quite clear, and it will be a favorite choice of all of us if we consider horizontal as x-axis and vertical as y-axis. We shall deal with projectile motion in similar manner, that is, it is going to be treated as a planar motion, and we are considering that particle is undergoing x-axis motion and y-axis motion at the same time. Particle is undergoing horizontal motion and vertical motion at the same time. In diagram A, here is diagram A. In diagram A, I have filtered, I have separated vertical motion of the particle. Particle, this is the particle, has been thrown with initial velocity uy. This uy is initial velocity given to particle along vertical, along y-axis. We consider vertical as y-axis. So uy is initial velocity imparted to particle along vertical, or vertical will be selected as y-axis also, and with this velocity particle starts, it goes up, it reaches the highest point, and at highest point its velocity becomes 0 so far as vertical motion is concerned. I am not saying that at highest point particle is coming to rest, but at highest point velocity of particle at highest point, velocity of particle becomes 0, and from there it returns back. In diagram 2 we have exhibited horizontal motion of particle. Horizontal motion is quite simple. Particle has been given a velocity ux. There is a horizontal component of velocity, and with that particle starts moving along this line, and this is a monotonous motion. Nothing happens to velocity, velocity remains uniform, though along y-axis, along vertical, particle's motion is accelerated. There is an acceleration which is directed vertically downward when particle is moving along vertical, or when we consider vertical motion of this particle or vertical motion of this projectile. And when these two motions are combined, you imagine that these two motions are going on at the same time, then the combined appearance is like this. This is combined appearance. when you combine these two situations, when particle is undergoing two motions at the same time, then this will be the appearance of motion of the particle. This will be path described by particle. Projectile motion is combined effect of vertical straight line motion and horizontal straight line motion. Vertical motion has acceleration, horizontal motion is free from acceleration. In the two types of motion, if the two types of motions are overlapped, mixed for the same particle, at the same time the two motions are going on, then the combined appearance is projectile motion. Projectile motion means particle describes a curved parabolic trajectory.